Okay, welcome to part 2 of lesson 5.4. What we want to do now is we want to look at um, actually coming up with, using a graph to make a linear model for each function and then describe the meaning of the terms in the models and then create the linear system and state what the solution represents. So if we look at this first one, we have two different lines here, and we've got some points on each line. We can see the point at which they intersect, 764. We'll talk about that in a moment and exactly what that means. So first, let's talk about this first line here. We have this point 057 and this point 764. If we want to find a linear equation for this, we can simply find the slope. I'm going to take the two y values, 57 minus 64 over 0 minus 7. If I do that, I get negative 7 over negative 7, which equals 1. So there's the slope for that line. And then I can put that into a linear equation. Y would equal x. Why just x? Because the slope is 1 plus 57. Why 57? Because that is the y-intercept. Right? And then for this other line here, we have the points 015 and 764. I can also use those. I know, once again, that the y-intercept is going to be 15. I can find the slope. M equals 15 minus 64 over 0 minus 7. It's going to equal negative 49 over negative 7. That's going to equal 7. So then my linear equation would be y equals 7x plus 15. And then of course it asks, what's the solution? Well, the solution is this point, 764, right? So that's the point of interest, 764. And then the question is, what does that mean? Well, what that means is that in 7 days, both of these functions will be at a cost of $64. And I know that the 7, the x value, that's the number of days. This is the cabin rental cost, so I know that at 7 days at $64, that they would be the same. Okay, let's go and look at the next example here. Again, use the graph to make a linear model of each function, describe the meaning in terms of the models, then create the linear system and state what the solution represents. We can do that for each. As usual, if we look at, for example, this first line, we see that the y-intercept, or b in this case, is 125. That's where the y-intercept is located. I can find the slope. Okay, m is going to equal 125 minus, you can see this point where they intersect, 230. And I can put that over, let's see, 0 minus 6, which equals negative 105 over negative 6. And so I can simplify that down to 17.5, and it's going to be positive because these two numbers are negative. So then that means my linear equation would be y equals 17.5x plus 125, my y-intercept. And I can use this decimal. I know a lot of times we avoid decimals in this class, but this is non-repeating. It terminates. Okay, as long as it's not a third or something like that that's going to repeat forever, we can use that number just fine. All right, and then for the other line, I can see that the y-intercept is 20. So b equals 20. And once again, I can find the slope. M equals 20 minus 230 over 0 minus 6. That's going to equal 35. Once I do all the math, so then y will equal 35x plus 20. And so what does this point mean? Well, it means that if we notice here we have film length in minutes and then the cost. So in 6 minutes, both films are going to cost $230. All right, in the next video, we're going to graph some systems of inequalities. So obviously there'll be a little bit of a difference, but most of the procedures and methods for doing that are still the same.